Article 220.56 of the National Electrical Code pertains to the calculation of feeder and service loads for commercial kitchen equipment. It specifically addresses the application of demand factors to refrigerators and freezers in commercial kitchens. The question at hand is whether refrigerators located in bars and hotel rooms within a hotel fall under the purview of this article, thereby requiring the application of the specified demand factors. The answer is no. Article 220.56 focuses on kitchen equipment, which is generally understood to be appliances used for the preparation and cooking of food on a commercial scale. These appliances are typically found in restaurants, cafeterias, and other food service establishments. The purpose of demand factors is to account for the fact that not all appliances will be operating at their maximum load simultaneously. This allows for a more accurate and cost-effective calculation of the required feeder and service capacity. Refrigerators in bars and hotel rooms, while serving the function of cooling and preserving food and beverages, are not considered to be part of a commercial kitchen in the same sense as appliances used for food preparation. They are typically smaller in size and have a lower power consumption than commercial kitchen refrigerators. Furthermore, the usage patterns of these refrigerators are different from those in a commercial kitchen. In a commercial kitchen, refrigerators are constantly being opened and closed as food is prepared, leading to a higher overall load. In contrast, refrigerators in bars and hotel rooms are typically opened less frequently and for shorter durations. Therefore, it is not appropriate to apply the demand factors specified in Article 220.56 to refrigerators in bars and hotel rooms. Instead, the load for these refrigerators should be calculated based on their individual nameplate ratings. This will provide a more accurate estimate of the actual load that they will impose on the electrical system. It's important to consult with a qualified electrical engineer or inspector to ensure that the electrical system is properly designed and installed in accordance with all applicable codes and regulations. This includes selecting the appropriate wire size, overcurrent protection, and other electrical components. The NEC provides specific requirements for the installation of electrical equipment in various locations, including hotels and bars. These requirements are designed to ensure the safety of occupants and to prevent electrical hazards. For example, the NEC specifies the type of wiring methods that are permitted in different types of occupancies. It also requires that all electrical equipment be properly grounded to minimize the risk of electric shock. In addition to the NEC, local codes and regulations may also apply to the installation of electrical equipment. It is important to be familiar with all applicable codes and regulations before beginning any electrical work. When calculating the load for refrigerators in bars and hotel rooms, it is important to consider the following factors. Firstly, the nameplate rating of the refrigerator, which indicates the maximum power consumption of the appliance. Secondly, the voltage at which the refrigerator will be operating, which is typically 120 volts. And thirdly, the duty cycle of the refrigerator, which is the percentage of time that the refrigerator is actually running. The nameplate rating can be found on a label attached to the refrigerator. The voltage is typically indicated on the same label. The duty cycle can be estimated based on the usage patterns of the refrigerator. For example, a refrigerator in a hotel room that is only used occasionally may have a lower duty cycle than a refrigerator in a bar that is used frequently. Once these factors have been determined, the load for the refrigerator can be calculated using the following formula: load equals nameplate rating times duty cycle divided by voltage. For example, if a refrigerator has a nameplate rating of 500 watts, a duty cycle of 50%, and operates at 120 volts, the load would be 500 watts times 0.5 divided by 120 volts, which equals 2.8 amps. This is the amount of current that the refrigerator will draw from the electrical system. It is important to ensure that the electrical system is capable of supplying this current without overloading. Overloading can cause the electrical system to overheat, which can lead to a fire. In addition to calculating the load for individual refrigerators, it is also important to consider the total load of all refrigerators in the building. This can be done by summing the loads of all individual refrigerators. The total load should be used to determine the size of the feeder and service conductors. The feeder and service conductors must be sized to carry the total load without overheating. The NEC provides tables that specify the ampacity of different sizes of conductors. The ampacity of a conductor is the maximum amount of current that it can carry without overheating. It is important to select conductors with an ampacity that is greater than or equal to the total load. In addition to sizing the conductors, it is also important to select the appropriate overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices will trip and interrupt the flow of current if the current exceeds a certain level. The overcurrent protection devices should be sized to protect the conductors from overheating. The NEC provides tables that specify the maximum size of overcurrent protection devices that can be used with different sizes of conductors. It is important to select overcurrent protection devices that are sized appropriately for the conductors that they are protecting. It is also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC specifies the requirements for grounding electrical equipment. These requirements vary depending on the type of equipment and the location in which it is installed. It is important to follow the NEC requirements for grounding to ensure the safety of occupants. In summary, refrigerators in bars and hotel rooms are not subject to the demand factors specified in Article 220.56 of the NEC. The load for these refrigerators should be calculated based on their individual nameplate ratings. It is important to consult with a qualified electrical engineer or inspector to ensure that the electrical system is properly designed and installed in accordance with all applicable codes and regulations. This includes selecting the appropriate wire size, overcurrent protection, and grounding methods. By following these guidelines, you can ensure the safety of occupants and prevent electrical hazards. Furthermore, it's essential to understand the distinction between Article 220.56 and other relevant sections of the NEC. While 220.56 specifically addresses kitchen equipment demand factors, other sections cover general appliance load calculations and receptacle circuit requirements. For instance, Article 210 addresses branch circuits, including those serving receptacles in hotel rooms and bars. These circuits must be sized to accommodate the anticipated load, which may include refrigerators and other appliances. The minimum branch circuit ampacity for receptacles is typically 20 amps for general-purpose circuits, but specific requirements may vary depending on the application and local codes. The NEC also provides guidance on calculating the total load for a building, which is used to determine the size of the service entrance conductors and equipment. This calculation involves summing the loads of all individual circuits, including those serving refrigerators, lighting, and other appliances. Demand factors may be applied to certain types of loads, such as lighting and heating, to account for the fact that not all loads will be operating at their maximum levels simultaneously. However, refrigerators are typically not subject to demand factors unless they are part of a large commercial kitchen installation. When installing refrigerators in bars and hotel rooms, it is important to consider the location and environmental conditions. Refrigerators should be installed in a well-ventilated area to prevent overheating. They should also be protected from moisture and physical damage. In damp or wet locations, ground fault circuit interrupter protection may be required to prevent electric shock. The NEC also specifies requirements for the installation of receptacles in bathrooms and other locations where water is present. These receptacles must be ground fault circuit interrupter protected to prevent electric shock. When selecting refrigerators for bars and hotel rooms, it is important to consider their energy efficiency. Energy-efficient refrigerators can save money on electricity bills and reduce the environmental impact of the building. Energy Star rated refrigerators meet certain energy efficiency standards and are a good choice for many applications. It is also important to consider the size and capacity of the refrigerator. The refrigerator should be large enough to meet the needs of the occupants, but not so large that it wastes energy. When sizing the refrigerator, it is important to consider the amount of food and beverages that will be stored in it. Finally, it is important to maintain refrigerators properly to ensure their efficient operation and long life. Refrigerators should be cleaned regularly to remove dust and debris. The door seals should be inspected to ensure that they are tight and prevent air leaks. The condenser coils should be cleaned periodically to remove dust and dirt, which can reduce the efficiency of the refrigerator. By following these maintenance tips, you can extend the life of your refrigerator and save money on energy bills. In conclusion, the application of NEC Article 220.56 is specific to commercial kitchen equipment and does not extend to refrigerators in bars and hotel rooms. Proper load calculations based on nameplate ratings, adherence to general NEC guidelines for branch circuits and receptacle installations, and consideration of environmental factors are crucial for safe and efficient electrical system design in these settings. Regular maintenance and the selection of energy-efficient appliances further contribute to a reliable and cost-effective operation.